Hey everyone, welcome back, and today let's solve Leetcode problem 1331 titled Rank Transform of an Array. So this is actually the daily challenge problem, or the special problem on Leetcode right now, and so I thought it would be a good problem to go over. So the problem statement says that we're given an array of integers array, and we have to replace each element with its rank. And the rank represents how large the element is, and the rank has the following rules. The rank is an integer starting from value 1, not 0, and the larger the element, the larger the rank. And if two elements are equal, their rank must be the same. So the rank should be as small or minimized as possible. So in example 1, we have the input array to be 40, 10, 20, and 30, and we would output 4, 1, 2, 3 respectively for every single value in this output corresponding its number that it actually has the rank to. So the reason why 4 is first is because it actually stores the value or rank for 40. And since 40 is the 0th element in the input array, 4 has to also be the 0th element in the output array, right? They have to be matching or at the same indices for every rank and its number. So 10 would be array at 1, or the input array at 1, and it's going to be the smallest element in this case, and so it would have a rank of 1. 20 would be the second smallest, and so that would have a rank of 2 at indice 2. And 30 would be the third smallest, or the second largest, and that would have hence a rank of 3, right, at the very last index, because that's how it's positioned in the input array. And so that's also how its rank is going to be positioned in the output. And so for the explanation here, it says that 40 is the largest element, hence it has a rank of 4. 10 is the smallest, 20 is the second smallest, and 30 is the third smallest. So essentially, the minimum value of the input array is going to be mapped or have a rank of 1. And the largest value is essentially going to have a rank of n, where n is the length of the input array. So in example 2, applying that same logic, since we actually have an array of 300s, basically the same exact element, we would simply output an array of every single indice or every single rank to be the same, because we have only the same elements, as denoted in this line right here. Right here, right? And you may be wondering, sure, every single value in this case is going to have the same rank, but why is it 1? It can be 2, 2, 2, it can be 3, 3, 3. Technically, theoretically, it should be 3, 3, 3, because that is actually the length of this input array. And the really major constraint here is that it says rank should be as small as possible. And so we want to minimize the value of the rank as much as we can. And so instead of adding 2, 2, 2 or 3, 3, 3, we'd simply have 1, 1, 1 to minimize that rank value and start every single element since it's equal at 1. So in example 3, we have the input array to be this long or large sequence of values. And so we would output 5, 3, 4, 2, 8, 6, 7, 1, 3. Where essentially 8 is going to be the rank of the largest number, which in this case is going to be having a value of 100. And since 100 actually is 0, 1, 2, 3 at position 4 or index 4, 8 is also going to be at index 4 to actually map the respective rank of 100. And you'd see we actually have the rank 3 appear twice here. And that's because at these indices in the input array as well, we have two of the same elements, 12 and 12. And since 12 is the third smallest element in this input, that would have a rank of 3 at these corresponding indices, because of course 12 is equal to 12. In other words, they are the same element. So with those problem statements out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution. And then I'll show you guys how I would optimally solve this problem in a bit. Okay, so honestly, this problem does seem pretty challenging and interesting of a question at first, but once you actually realize that you really just need to sort this array and sort every rank with this corresponding value like that, this problem really becomes pretty trivial. And to better visualize that, let's just go ahead and dive straight into the code, and I'll explain exactly how it works line by line. All right, note a quick tip here that this is only 3 lines, and so it won't be too complicated of code. It might have some weird syntax for any non-Python users, but it isn't too bad of code, and it's really simple to understand. So first, we want to simply get the sorted of the set of the array. And the reason why we actually get the set is because we don't care for duplicate values, because we know for any value or element in this input array, it's going to have the same exact rank. And so we'll set a, basically I'll literally just call it unique, and I'll simply, unique, and I'll simply set it to the sorted of the set of the array. Again, what this does, for any of you guys who don't or are new to Python, this simply gets the set of the array, basically removing all the duplicate characters, and it stores it in the unique of the sorted form, as denoted by the sorted keyword in Python. So it's in the unique variable, we store the sorted of the set of the array, removing all duplicate characters and sorting it in ascending order. Once we do that, we want to actually initialize a hash map that maps every single value or number in the input array with its corresponding rank, or in this case, since we sorted it, its corresponding indice, because it's in already ascending order from least to greatest. As we know, the larger the element, the larger the rank. So I'm literally just going to call this hash map, since that isn't actually a keyword in Python. And again, I'm going to initialize it to be basically every single number corresponding with its rank. And I'll use some list comprehension. I guess in this case it's dictionary comprehension, but I'm simply storing every single number with its rank as I loop through for the every num, or rather for every rank and num in the enumerate of the array. And what the enumerate function or iterator really does in Python is it simply loops through the input or an iterable, but simply stores every single character or number with its corresponding rank, or I guess in this case, indice. Okay? So it's a good way to actually loop through things when you actually want to store every single indice and number correspondingly or consecutively when you're looping through iterables, which in this case our iterable is an array titled literally ARR. So once we actually initialize that hash map, we can literally just return a list of the hash map at every single value n, where every hash map at n is its corresponding rank or indice because we sorted it for every single n in the input array. But there is actually a minute bug in this code, and although it is pretty minute, it will actually serve to be a huge issue when we actually submit it. And the issue actually is that we correspond every single number in the enumerator or looping of the traversal of the input array with this corresponding rank or indice as denoted by the enumerating keyword. But we know that every single array in Python and in programming in general is going to be 0 indexed, meaning the first element or the very initial element that we see is going to have an index value of 0, not 1. And we know that rank is an integer starting from 1, not starting from 0, but starting from 1. In other words, the smallest value is going to have a rank of 1, not a rank of 0, or in other words, not an indice of 0. And so we actually have to correspond every number rather than just its rank, but its rank plus 1 to account for that right shift, as essentially every single rank is going to be 1 greater than its corresponding indice because we start from 1 rather than 0. And as you can see, if I were to submit this code right now, unless I made any syntax errors here, this should actually be accepted. Let's see here. I probably spelled something wrong or something. Let's see. Enumerate of array. N. Okay, let's see here. Okay, so this should actually be sorted, or unique. Sorry, accidentally typed array there. But as you can see now, this actually will be accepted. And to better visualize what this actually does, we'll get unique to be the sorted of the set of numbers, removing all duplicate characters and sorting that in ascending order. Then we'll actually initialize this hash map that maps every single number or element in this input array with its corresponding rank plus 1 to account for that right shift, as every single rank is going to be 1 greater than its corresponding indice. And the way we actually get every single indice is to basically enumerate through the unique iterable by storing every single rank or indice with its corresponding number. And once we actually map that, we can simply return an array of hash map at every value n for every n or element n in the input array. So as you can see, this is going to have a runtime complexity of big O of n log n, because of course we are actually sorting this array, okay? And so to sort any iterable, it's actually going to take big O of n log n time, which is actually slower than big O of n time, but that's completely fine. It is still very efficient, and this is going to be big O of n time because we actually do use an extra hash map to store or map every single number with its corresponding rank. Technically, it's big O of 2 to the n, but that doesn't really matter, as really coefficients in runtime complexity is not that big of a deal. It's really just going to be big O of n. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.